here to talk about AWS Lambda. I'm Martin Smith. As Clint said, I'm going to be kind of here and not here a lot this next year. So this is kind of the last meeting I'll be at, but I will be watching the stream, and hopefully after the meeting, it helps to have more than one person organize stuff like this. So if you're at all interested, you don't have to do it all. It's just about doing one little piece makes a huge difference. So if you're interested, hopefully we can talk about that after the meeting. We'll turn the stream off so there's no evidence of you committing to doing any particular thing. It'll just be your honest word. So yeah, so I'm a DevOps engineer. I work at Rackspace currently, and we have some questions.
The volume goes way up when you turn your head right and way down when you turn your head left.
Should have left my collared shirt on, huh? Let's see. How about that? Because I'll be looking at the slides the whole time.
Perfect.
Maybe. One of those. Next time I'll wear a collared shirt. We'll have to add that to the checklist in a year. Yeah, right. So I'm here to talk about AWS Lambda. I don't know. Maybe I should just hold this. There you go. Hold this.
Put it in the middle.
Put it in the middle. So that's still better than. How about lower? I know it messes up the game. Is that better?
Put it to your ears so it
How's
follows.
that? Yeah. Let's see. How's that? A little better?
Yeah.
All right. Warn me if I lose it. Yeah. So actually ask questions. That's a great segue. Stop me at any time with questions, because really this is just about. Well, I'll tell you what it's about in a minute, but it's about you guys and convincing people to try Lambda, check it out. I'm not necessarily that expert at it any more than anybody else. It's still so new that there's a lot coming out, so you may know or even have ideas that I've never heard of. And I've actually even got a few examples today of things that literally were posted today that could not have been better topics for this talk. So I wrote it last night, which was apparently too soon. But as I said, I'm a DevOps engineer at Rackspace. That's me on Twitter and the blog and email and GitHub. I've been doing various things around programming and systems administration for 15 years. That's weird math. I worked at tech places in high school and middle school, so I'm not that old. I also see that's good. All right. I also have an unhealthy obsession with acquiring new hobbies. I like to put memes in presentations as well, so there's lots of those, so excellent. And I like photography, knitting, baking, kayaking, languages, travel. I gotta stop. I gotta just pick something and actually be good at it. Because I'm kind of so-so at lots of those things. But that's the basic background about me. And I'll post this presentation online too. Maybe I'll even try to get a blog post out of it or something. But this is the plan. So I'm going to tell you what Lambda is, why I think it matters, and then maybe a demo, which are live demos. Don't try them. And then maybe some limits of Lambda and why maybe it's not quite there yet. So that's the plan. Does that sound good to everybody? Is that what you're here for? This is you get on the plane and they say the city you're going to. That's not. This is what you're here for. All right. All right, cool. So actually I lied a little bit. First, I want to just tell you the whole point. You're not going to have to wait till the end of the presentation. This is really good value here. I wanted to tell you, you should try to use Lambda. It's really easy. Go home, and I'm going to explain some of this as we go along, but it doesn't cost you anything. You should use it to, do you ever write cron jobs, batch jobs? We still call them batch, called ETL now, right? It's a cool acronym for batch jobs. If you like RESTful APIs, or you could even write your entire application in it. So if you don't get anything else out of this presentation, I would say go try it. It's actually really easy. I know that there's probably people here who've never touched AWS. I'm going to try to talk about that. I'm going to try to talk about Lambda specifically, and then go all the way up to the 10,000-foot pie in the sky view. But if you don't get anything else out of this, just go try it. It's so simple, and it might be the future. That's what I'm going to try and convince you of. So that was not in the plan, but all right. So here's the plan. What is Lambda? So a quick background on AWS. Started in 2006. Let's see, Amazon moved to AWS for their e-commerce platform in 2010. You think about that, that's only 5 years ago. So it feels like people have been talking about AWS forever. Maybe I'm just sick of it. I constantly hear about AWS, and it's only 5 years old that was there before there was an e-commerce platform on it. So before that, there was like a whole bunch, there's a whole list of people that say they were in before Amazon, but it sounds like it was a pretty shaky platform before that. So also Netflix was their first like notable customer and outage in 2011. And their first customer event ever was in 2012. So that's not that long ago, 3 years ago. Like if you've been to, I mean, OSCON, the O'Reilly conferences they do, I mean, Velocity's been around almost as long. Like, and Velocity's like way cool, like super future-facing conference. It's only been around about as long as Amazon's been having customer events. So according to Jeff Bezos, it's a $5 billion business in 2015. No one can verify any of this, right? Like, so there's like a whole, if you want a job as an analyst, just go estimate what AWS or Amazon are worth, because it's like, it's changing all the time, and there's good job market in it. So what is AWS? AWS, and this is really how people got to it to begin with. So there's like a virtualization platform, right? That's called EC2, Elastic Compute Cluster. There's a bunch of other compute products. So, but if you came from models before that, you're talking virtualization and some networking. But look how many products there are, right? Does anyone use AWS like all the time? Nick, Bjorn, no, two? All right, so Derek, we're gonna quiz you. You have to name all these and what category they're in a little bit, right? No? I mean, I think I've got a screenshot of their control panel. It's like, when I first logged into it, I thought, oh, this will be easy. Why are all of these color coded? Now I'm like, I know it's green. Where is it? Like, I'm looking for, it's terrible. It's the worst UI. But anyway, they've got a lot of products. They've got storage, databases, configuration management. They can sync your Active Directory to their something, I don't know. All kinds of stuff. Mechanical Turk, I threw that one in because it's like the one weird thing that, there's actually a few other weird things, but it's one weird thing that doesn't fit with any of these. It's like, our business is all of this cloud stuff, and then like this, I don't know what you'd call Mechanical Turk, like sort of weird part-time slave labor thing, right? It's like, cars. What'd you say?
Uber without cars.
Uber without cars. That's good, actually. I like that. And you don't have to drive anywhere either. You can just like stay at home.
You're sharing your spare time.
That's right, your spare time. It's
and
like
the internet connection to your hut.
We are gonna brute force this, even if we can't figure out an algorithm. We're just gonna put human brains on it. But anyway, so bunch of things there. I'm tired of all those things. This is more memes. But Lambda is the one we're gonna talk about tonight. It does tie into all of these other things, but I'm just gonna kind of stay with Lambda. I'm gonna assume people aren't too familiar with the other ones. There's tons of integrations, and there's tons of like, 2 months ago it didn't do this, and today it does that, and with all the other Amazon services. And I can talk about those if there are like specific questions or interests, but I'm gonna try to mostly just talk about Lambda. So all this stuff, you don't have to know about all this stuff. I'm just gonna talk about it. All right, cool, does that sound good? Yeah. All right, so I'm just gonna fill the first part of the presentation with memes, and you can see where I got tired, you'll see. So why me? So I've actually been approached by a few presses and done book reviews on books about Lambda. Some of the tech presses I've done contributed to some open source projects that do various things with Lambda, one of which I was hoping to tell you about, but I'm waiting for a blog post to be posted about it, so I'm gonna hold off. I'll just kind of point you at the repo. And I've been using Lambda for a few months, so really, like, I don't know that much more than you. I'm like 2 months away from when you've heard of it, and really I started using it because I started supporting Python. So that's kind of, I probably don't know that much about it, but there's really cool stuff I can tell you about that other people have done with it too. So that's kind of where the presentation ends up. So let's see, so Lambda, I assume it's named after Lambda calculus, computer science majors. Anyone ever heard of this? Like, Alonzo Church, Alan Turing, that kind of stuff. So I assume that's what it's named after, but there's probably a whole bunch of other horrible stuff. This is like one of those things, if you Google it, you're gonna get trolled on some other topic. But turns out that the next big thing might be running code without servers, right? The cloud kind of turned things around, I would say, from virtualization and networking, like was a big thing, right? That like people were doing things on physical hardware. Then the cloud came along and it was like, oh my gosh. And then people started talking about immutable infrastructure, treating servers. Has anyone ever heard servers as cattle, not pets? Right? Like burn it down and try again. You don't treat these things like they're your pets. And then maybe Lambda is the next big thing. But what Lambda is at its heart is just you upload some code to an endpoint, right? And it's a function, it's a callback, it's an event-driven, kind of like some of the first languages it supported, Node.js. Everything is a function with a callback. Lambda is just a place to say, here, go run these lines of code. That's it at its heart. But I'd say the devil's in the details there. Questions? Yeah, so event-driven and stateless, which is something that I think when you follow that timeline from like virtualization and shared storage up to like the cloud and then to like maybe, all right, we have infrastructure on demand, we can provision through software. Suddenly like everyone's like, all right, how do we make this like crazy parallel? And talk about things like event-driven programming and making it super parallel. Actors, like you said, is another paradigm for that. And there's actually a lot of science, I think, around this in computer science about, processors aren't going to get a ton smaller, maybe, we think, although we've said that a few times and things have changed. But if they're not going to get a ton smaller, then it's like, how do we make things faster? Applications are getting bigger. Parallelization is the way people are talking about doing that, and Lambda kind of fits into that model as like, well, and this is something you're not going to have to worry about, right? So I'm going to tell you about that too. So let's see here. So this is just, I just wanted to get right out in front of you early an example of, this is Node.js. This is a function. You literally save this in a file and upload it to AWS. And then you get some options for how it's triggered. You can say like, do this, more recently you could do like a cron job type style where you run this on a schedule. Before that, you could do some event-driven stuff. You could say every time a file is uploaded to this particular website, every time, there's all kinds of event-driven things, and then there's also some things where it can poll. And some of AWS's other services have that polling is some place for it to draw events from. But yeah, so really simple. This one just logs some output. And then, I learned this the other day that it seems weird because Lambda, like there's this context succeed. You can like say I'm done. That's at the bottom of the function, and you may not even Node.js might not even at a runtime exit. It might just get destroyed by AWS as soon as you call it. I'm done, right? Like you don't have to wait for memory to be reclaimed. It's very like instantaneous, and it's basically a single-threaded model. And what's cool about it is that, so this has been around since November 2014. This is AWS released Lambda, announced it as preview. Node.js is what they supported. In 2015, in June, they added Java. So sorry, the Java one doesn't wrap well. But similar thing here, basically import some class, you return whatever you want. It's basically the same example, just returning a string. So that's Java. And then more recently, which is kind of where I came into Lambda, was Python. And so they started supporting Python. So also, I want to say, like, maybe supporting Python. A lot of these languages have native extensions. They've got, trying to think of other things they've got, like, I know I've run into PyCrypto and OpenSSL trying to use like my own version of that locally. You can't upload it to Lambda. And I'll talk more about why that is, but same thing if you're trying to do like Ruby or Go. Go actually is one of the nice ones with Lambda, because Go is so platform independent, that you generally can package up and ship like statically linked everything with Go. So there's actually a few open source projects out there just to package things in Go and like wrap them up in Node or in Python or Java. So, but anyway, at the heart of it, it's just this function call. And let's see, I want to kind of go back a little bit and tell you about the pricing, because I felt like probably everyone was going to be like, AWS, that's expensive. So they price it with the number of requests times the number of gigabit seconds, so that's the memory usage, and how long it runs. So you're looking at these two, you, I think, add them together. I don't know why I put a star there. I think they're additive. And I have some examples here, but they price it monthly, so every month they calculate this. And they give you 1 million requests for free every month, and 400,000 gigabit seconds of memory free every month, memory runtime every month. So this is why I say you should go try it. It's like 0.0000002 cents per request. So very cheap. You could go try this. You could run, I'll tell you some of the cool things you could run on it, but you could run all kinds of cron jobs you have now. You got a website, you want to run something on an interval, send an email, screen scrape something from the web. Go try it right now, because it's basically free for anything at that sort of that bottom level. And I know a big criticism of Amazon is that it's hard to calculate what your bill is, and there's a whole like third-party market and tools to help you figure out what your bill is. But there are tools in there where you can say, tell me as soon as I've gone over this, right? So you could do that with something like CloudWatch or a lot of the third-party tools. But it's basically like free for you to try this. And I thought before I told you much more about Lambda, I would even show you. Yeah, so that's the.
This is the price after you're free.
After it's free, that's right. So this was, yeah, gigabit seconds. Okay, so yeah, these are added together. So 20 cents per million requests plus some memory. I don't need a lot of memory for the things that I run on Lambda, and that's partly because the model they've given is basically after 60 seconds you're cut off. You can't have a long-running process. And you can actually set that timeout lower. So you can say, if this takes more than 5 seconds, cut it off. And I don't know. I mean, I don't have a lot of stuff that consumes a ton of memory. I have a really interesting example for you, because the way AWS often works is that memory and CPU are paired. So if somebody wants to use more memory, they get more CPU, or if they want more CPU, they get more memory. So there's some interesting stuff there. But I have a really good example that speaks to that, and also speaks to the value of Lambda, I think, later. So, but here's some examples. So 512 megs of RAM for your function, 3 million times. It ran for 1 second, cost you $20 for the month. That's not bad. I don't think. You guys think that's cheap, expensive? No, 1 second. I don't know. Could be like a web server, but I don't get 3 million requests on my website in a month. So, and I probably end up, between a domain name and hosting, end up paying like at least $10. Does that seem expensive, or sticker shock? Cheap? No. I don't care. It's on my company's credit card. I don't know. It's really not bad for some of these. And if you look at it, like most of it's compute. It's $18 a compute and 40 cents of the requests. So it's actually very, very cheap. There's some interesting estimates out there about people switching to something like this instead of what they've got now, and whether they really save money or not. But so one other example, yeah, Clint.
How does it get to data? Do you have to have that stored in
So that's an excellent question. This is all back to that model of stateless and single threaded. So you have to go reach out and get that data from somewhere. There's no data that that's built into it other than the software you upload. I think you could probably upload some other stuff in there, like if you were to encode it in your source code. But yeah, you cannot get any. There's no functionality built into that. You can go talk to one of Amazon's lovely other hosted services for that, right? And you will pay for that. But there's some people that have done that math and it's worked out for them that it was still cheaper to use this, especially when they don't have to run servers. So, and maybe I didn't say this yet, but the other selling point for Lambda is that it's going to scale up. So you're basically saying no servers and no state, but Amazon is going to make sure that however many of these you want to run, it's going to scale that up for you. You're not going to have to worry about that. So, and there's people doing genome sequencing with this. There's people doing load testing, all kinds of things. Like that's been borne out by people's experience that it does scale pretty well.
It does seem like there's some risk though, if you write bad code or somebody
Yes.
hacks you. Or
There's some risk if you write bad code or you get hacked. Absolutely. It's interesting because I saw that in a debate in a thread not too long ago, I think on like Reddit or somewhere, and someone was like, well, when I run Apache Bench against your website, like, I hope your hosting provider gives you free bandwidth, right? Like, it's going to cost you somewhat if you get DDoSed or write some bad code, no matter what platform you're on, unless you own your own,
right.
Which is, I mean, I think that there probably is a plateau for the cost of like cloud versus hosting your own, and maybe once you're spending enough on cloud that it's cheaper to run your own, you do that. But
I'd rather have my server fall over than get a $3,000 bill.
okay, so for the stream, I would rather have a server fall over than get a $3,000 bill from Amazon. I guess
You can limit it though, right?
so. It is unlimited as far as like they'll be happy to bill you more than that if that's like unlimited billing. That's what you mean.
There's a setting you can say shut off before.
Yeah.
You can do, yes, you can set some limits. I thought you said it's unlimited. No, you can limit it. Yes, that's right. So there are things you can do to mitigate that, but ultimately, I think like this is also competing against other similar things that are in this space, which is like startups that don't want to run infrastructure, and like whether it's Roku or almost even in a data center, you get charged bandwidth, right? Like if you get DDoS in a data center, they're not like, it's okay, your server fell over. They're like, you're getting DDoS, turn this off. Like they're, you know what I mean? Like, so it's still an impact.
Yeah.
I don't know. So sounds like people feel good about pricing. I'm just gonna be like,
on that,
oh, Derek,
yeah.
question.
Do you
or
have
comment.
any question? Do you have any evidence? So there's oftentimes like mitigation strategies AWS employs, like on their load balancers or EC2 like public addresses. Is that roughly the same on this? Is there any evidence? Like,
so there's been people that have benchmarked Lambda, the service, and from everything I've seen, I've never seen any mitigation strategies. I'll tell you from what I know from being in the industry, which is that it's more of a partitioning strategy. Usually it's like all the bad people go to these servers. And then like all the people who are not getting DDoS can run on the rest of our infrastructure.
right.
So that's like generally what I've seen, but the people that have benchmarked Lambda have not, they've seen, I think, what was it, like up to a second from when you make a request to when your function starts running, just so like ridiculously low. And I think after that, like 100 milliseconds or so for repeated invocations, once it's like warmed up.
Right.
And so like in the background, and this is kind of understood, and I get into this in a little bit too, is that they're basically spinning up servers and running these and trying to keep everybody insulated from everybody else, right? Like there's no real magic here. It's just that they're going to patch the servers and they're going to rotate out the kernel when there's a vulnerability and that kind of stuff. So no, I've never really seen anybody that that has run into, or I have not run into myself, any sort of mitigation for DDoS and things like that. I will say a lot of people put Lambda as like something in the back of their infrastructure. So some of those serverless architectures that are in the title of the talk, which are later, I have 49 slides, this is number 17. So, but in some of the later ones, there's some examples where people are basically using Lambda to respond to API requests for mobile apps or single page apps like Gmail or something like that. So oftentimes they have to expose a little bit of it to the public, but they can also get away with maybe keeping a lot of it on somewhere a little more private or restricting who can talk to it. And what's nice about AWS is the security model is like gargantuan, so they can restrict a lot of stuff. But no, I've never seen them not. I've seen AWS come tell people when there are problems, like, "Hey, this looks weird." I've never seen that. I've never seen them go, "Oh, we're having trouble," or something like that. So I learned today actually that the way they do, and so like I work at a cloud computing company, and stuff goes down and people get refunds, right? I mean, I think that's like a fact of life. And so what's interesting about AWS, and I'm not like an account manager kind of person, but they look at your bill for the month before to figure out how much to refund you this month if they've like had some sort of degradation of service. So they're like, oh, you had 1 million requests last month because you're Netflix, like, so we're gonna refund you 1 million times the cost of this service. But if you're like got a small website or you're unlucky and you've scaled up really high since last month, you get only what last month's refund would look like if you'd actually been able to use the service. So I don't know, it'd be interesting. Again, numbers will never know, but really interesting.
Sometimes they publish like we are doing something magical over here.
That's true. Jeff Bezos will make some sort of statement about it. But yeah, it'd be interesting. Oh, if it ever became a public company, there'd be so much data, right? Like you'd learn so much. So yeah, I mean, that's a good question though. If I ever hear of it, I'll come back and I'll let you know. Let's see. So yeah, so that's just a little bit about Lambda, and why it matters is that next step in the plan, and my goal is to tell you about some of the ways people are using it here. So this might even fill in some of what it is, but do you feel like I kind of went fast through that part? Does that make sense? Like this place to just run some code. You know, the idea with cloud is that it's like compute as a utility model. This is like not servers as a utility model, but function calls as a utility model. So it's kind of like drilling down. It was like from one level to the next. Yeah, okay, cool. So why it matters, I did mention there's a lot of potential for integration with other AWS services. You know, if you haven't checked it out, it does have like a pretty steady lead in this space as far as like other cloud providers. What's interesting about this particular service is and I have this in like the limitations section, but everyone's worried about lock-in with these things too, right? So what's cool about Lambda, and that I can't make this claim about other AWS services, but what's cool about Lambda is that it's really still just Python, right? And so like they tell you this is the image we run these on, right? So if AWS somehow, seems unlikely, but if you just start, let's say you win the lottery and you don't want to give any more of your money, it's a happy thing. You win Powerball, you're like, I'm done with AWS. You can run this yourself on the same images that they run it on. So it's a little less locked in than some of these other things, but there's definitely some other cool integrations. There's, let's see here, so there's a message queuing service, right? So you can trigger these function calls off of messages. There's a great demo on their blog about a guy who did, you've all heard of like paste bin, paste some text. There's a squirrel bin, right, where you can, which I guess has pictures of squirrels, but is actually about, I guess there's another meaning for Acorn, which is small bit of runnable code. So it's like runnable code instead of just some random text. So there's like nicer syntax highlighting. It's kind of like a fancy paste bin. You could run a site like that. People are doing that with Lambda and some storage and no servers at all. So like you could probably even scale this up to the point where it replaces your web servers. If you're using their database service, replaces your database. No more managing servers. Like, I mean, there's pluses and minuses to that, but at least you know they're not going to wait for you. They're just going to replace the images. That may be bad for you, but look at all these things that you could at least trigger off of. So I can't even read them all myself. I just thought it was ridiculous how big the list looked. So there's some cool stuff with S3, which is their storage. I don't know, there's a whole bunch of neat stuff you can do there. So here's some of the ideas. I said you could replace cron. There are people replacing Unicorn or Rack, which are like web server frameworks, with it entirely. Let's see. It's kind of like instead of running web servers, the cloud is the web server, and you just give it code to run. As I said, very parallel friendly. They can scale it up for you. I know Derek's got a project out there to back up database instances using Lambda, right?
Oh, backup database, CDS, and
Databases, block storage, S3 to Lambda. It could replace Heroku. There's actually some interesting conversations out there about whether Heroku, which is a site where you can push code to and have it automatically deploy, whether really like Lambda is just a more general case of this, and then maybe this is a model where I think we've seen in the last few years that platform as a service has kind of exploded, and some people do it well, and some people don't do it. And everybody tries it, and maybe like Lambda, maybe people get into something more like Lambda instead of these like one-off APIs. Like right for us, here's our API. You can just use Lambda, and it'd be much more generic. So and could replace fast CGI. It could be replacing single-page apps. I don't think I mentioned it yet, but so AWS has a CDN service, right? So people are serving HTML, and it's out to edge nodes and highly available around the world, and their HTML is just making calls into Lambda to get, and then Lambda is going to the database, or Lambda is going to do some other message queue or something like that. But you could run the whole thing without ever touching the real servers, which is kind of cool. And somebody said that to me a couple of years ago with another CDN service, and I thought that just sounds terrible. That sounds like such a workaround. But I think like for the first time seeing it in this form, I would say it's actually pretty possible. And in fact, this morning there was a blog post I was talking about that I saw. David Guetta, he's like what do they call that? EDM, another awesome acronym, electronic dance music. The guy he's done a bunch of like sort of electronic music. His site just turned over to using Lambda, CloudFront for CDN, and a database, and AWS's API gateway service too. But no servers. Like that's a major musician. I don't know if he's like a top 50. He's probably a top 20. I don't know. So you're seeing this out there in the wild, which is really cool. Let's see. I was going to see if there's anything else interesting about it. I can show you the link for it too. But they've got a great sort of architectural diagram. You usually don't see people share that. They'll lose their competitive advantage, I would think. So some examples of other things people are doing with Lambda. Here's one. Sort of like Instagram, basically, right? Like, and I think Instagram is a heavy AWS user as well. So I don't know how much of this is something that folks at AWS wrote, thinking, look what you can do based on an actual customer, or whether it's just a hypothetical. But there's some examples where they just have a mobile client and a web client with a single page app, and basically image processing, sharing, social stuff, all through Lambda and a CDN. So you need a web server somewhere, but that's another platform as a service that's a lot safer without running code on it, just HTML files.
What kind of access, like library access, do we have here?
That's an interesting question. Amazon's very specific about what you do and don't have access to. So like for instance, I was recently doing AWS, I was working with AWS and moving some stuff there, and I wrote a Lambda job for validating with a bunch of files lying around that help you connect to different customer chef servers. And I need to validate that they all work. And so it turns out that there's some crypto libraries that I needed, and I couldn't get it to work. And what ended up happening in that case is that the libraries were on their image, but I was not uploading those libraries. So I was building my PyCrypto library again, so it's local. So I had to go get their image and make sure I use the libraries in their image. If it's not in their image, you got to either ship it by building it on their image and then putting it in it's a zip file you upload. And I don't use zip ignorantly. It actually has to be a zip file, not just any general archive. So you can upload it. You do have to worry about there's some maximum size things there. I think it's like 50 megs now. It's a maximum size, which seems huge, but I guess if you have OpenSSL statically compiled, maybe, I don't know. But you do have to worry about that some.
Because I'm doing something now where we're dropping files into S3,
Mm-hmm.
and then thinking about taking Lambda and running some custom C and C++ code.
Okay.
So can we do that?
Yeah, in fact, one of the examples in one of these slides is this is really cool. It's people that are doing. Has anyone heard of CRISPR? It's like a gene editing methodology. They're using C++ extensions to call into C++ from Node.js, and they actually whittled down their like $40,000 bill to $60 a month. And they're I guess when you do gene editing, you have to make sure you don't edit other genes by accident. And so they have to do all these crazy searches to make sure they don't edit other genes by accident. And they actually switched to Lambda, and their code was all in C++. And I can, the notes, so this presentation I'll post, but there's presentation notes in here too that have links to these projects. So if you want to check that one out, I don't know if they share their source though. I have to send them an email. Here's the squirrel bin one. So other really interesting, just using Lambda, some CDN, and some storage, some S3 buckets. Really, isn't that an awesome logo? I just want to make that for the logo because it's like another meme, can I say? But AWS has a blog post with this as an example, so I thought this would be a good one because you could also go back and look it up. And this is not just mobile apps, it's also the single page apps. It's a lot of back-end stuff. If I were Netflix, I'd use this for transcoding. They probably did that like 2 years ago. Now they've invented something else, but definitely lots of options there.
Sorry.
Yeah.
On the last slide, and now not for anyone specifically, but as they've split up each of their calls into Lambda, have you ever seen customers who, as they scale up and they're thinking about, oh, do we keep this on Lambda or do we move it to a server? Have you seen people try to customize, or try to optimize individual calls? Are they looking at this and saying like, oh, this call runs really long and that's not something we expect. Maybe there's something we can do about that.
I've read about customers doing that. Like there's public, I've read on white papers about people really looking at that.
Yeah.
Mostly because, but they're doing the optimization of like what's the slowest call, and they're not just looking at all of them. They're just looking at the biggest win for optimization.
Well, it seems like when you're getting metrics on like individual calls, like you can start to do like, oh, that costs a lot or takes a lot of time.
That's right. In fact, it's a theme on AWS. You actually see like people keep different accounts so that they can have different billing groups just by prod, test, and dev. So yeah, when you get down to that level, it's like, that production costs you this much a month, and that like this function call costs you a third of that. And yeah, you do see, I have seen that. In fact, that same gene editing example, that was something when because they were one of these examples where they were high performance compute, and people were saying if you did it yourself, it'd still be cheaper. And they were like, no, like we did it. In fact, and not only did they do that, but they actually, in some cases, let their calls run longer because it's cheaper than doing, like, depending on how much memory they pick for their Lambda function, they found that it might be better to let the calls run longer but pay less in memory. So, because I think as you saw in one of those pricing models, sometimes the memory can dominate the costs. So they were finding that if it takes 2 seconds instead of 3, or instead of 1 second, then we actually end up paying less. And like, as long as we don't turn off the wrong gene, and it's fine. Like they still return these requests in very little time. So Yeah, they have an interesting setup. That was like I think that was in a comment section on something they posted. It was a really interesting conversation where they were like, no, actually, we want it to be slower and we pay less. And it's still such a minuscule amount compared to what they were paying
$550
with real hardware. Yeah.
Right.
Yeah, it was something like less than $100 a month. And they had like HPC hardware before that. So, in fact, you can use Lambda to deploy Lambda. So this is something that there's a lot of tools out there to do things with Lambda, but the more I see them, the more I think, well, I would just write that in Lambda. So instead of, this is an example that you could do replication. So one thing with Lambda is that it's region specific. AWS has different regions. But it turns out if you can just upload to one of those regions, you can have it like replicate to all the others, right? So S3 buckets replicate. You can trigger events off of those buckets. So you can have a Lambda uploader sort of that you bootstrap by doing once manually in every region, and then you upload some Lambda code, and then it replicates out on S3, and then that triggers an event to run the Lambda uploader in every region. And you have this like distribution where you can actually take a function, upload it to one place, and have it spread out across the globe. Skynet. But really like interesting stuff, you know, when you start to say, all right, I'm going to use Lambda to do the thing that I'm doing with Lambda. And it starts to get very meta. In fact, there is, I don't know if I have a screenshot for it, but there was one where these people were doing like load testing, right? And they were just like kicking off a new test every time they ran a test. And it was like this tail recursion just for load testing. And so like I thought, surely like AWS would say, hey, this looks like runaway something. And they reported that no, in fact, that was actually totally fine. And it worked great. It was a great way to load test. And they didn't have to even manage servers, which if you ever do a lot of load testing, managing servers kind of sucks. When you have like all of these load testing boxes and you don't ever touch them, and then you have a new release and you have to do a bunch of stuff with them all at once. So interesting as a load testing platform too. Let's see. Yeah, so here's the one that I was talking about with gene editing. And they actually discovered that they had this graph of like, they also wanted the throughput. And so they were looking at like how much memory we give it and how much throughput they're getting out of it. And I guess when they did EC2, this was like a straight line, like, or even like all huddled around some low points, I guess, depending on what types of instances they picked for EC2. But it turned out that it scaled linearly on Lambda because as soon as they buy more memory, they get bigger instances and don't pay for it. Whereas on EC2, you pay a lot more when you get a bigger instance. The price point was better with Lambda. Does that make sense? So yeah, I guess they have to look for 20 base pairs that occur at the beginning of gene and then make sure it's not anywhere else. So they went from thousands to $60 a month. Lambda has a CPU to memory ratio, whereas the EC2 CPU to memory was more expensive. So
CTO was earning his paycheck.
yeah, right. I hope whoever saved them thousands down to $60 a month got a little bonus out of it. But the list goes on for things people do. There's people doing machine learning with it. Some stream processing. Amazon has like a Kinesis, which is like a big data, I guess, data warehousing thing that I've never used. But now they support Elasticsearch. They're doing all these different services, right? And people are using Lambda for lots of them because they don't want to run servers anymore. They used to not want to run data centers. Now they don't even want to run servers. And now it's just functions. So I would argue that it's the new normal. There's a new instead of so I don't want to run a mainframe and I don't want to run a data center, and then I just want to run VMs. Now I don't even want to run VMs. Now I just want to manage literally the piece of code I care about. So it could be completely a replacement. I mean, when people first started doing virtualization, they just thought, oh, well, I'll just use EC2 and S3, and that was a thing. And That was kind of led them on to things like I was talking about with cattle, not pets for infrastructure, self-healing infrastructure, automated provisioning, things that now they're using orchestration frameworks to sort of shoot a server in the head and just spin up another one, right? And even Amazon has that, like an elastic load balancer. And so like maybe instead of that now, the new paradigm will be Lambda, just functions, kill the function if it's running too long, don't kill the server. So I would say it's got all the right constraints too, right, for another revolution in this. Like people are just kind of playing with it and they're going, oh, it can only run for 60 seconds. And oh, it can't have any storage. It has to be stateless. Like these are things that in like the sort of CPU-bound programming world, people have been thinking about how to make the next revolution with for a long time. So maybe this actually will do it. And that's why you should go and kick the tires on Lambda. If for no other reason that this could be, like, if you barely miss the cloud thing and you're still on your data center, like just skip it. Just go to this. It's going to be the next thing. You heard it here first. Yeah, just skip it. Servers are bad. And here's like a little diagram of that, right? Of kind of containers came in here, like at some point, and they'll probably stick around for a while too. They probably will be virtualization and be around for a while, but I think that like most minimal container is just that piece of code you want to run. And I don't know if I'm thinking of this now, but one thing to keep in mind with libraries too is you can run multi-threaded, multi-process things. You just have to kick them off inside that function. So it's not like you're necessarily limited by single-threaded model, but it's really designed for that. If you can chunk out your work, that's the way to go. So yeah, here was one sort of comparing some of these. So let's see. This was a startup saying if we had this many customers, we'd think like this is how much we would pay based on their number of requests. And then Lambda, DynamoDB, S3. And if you looked at a lot of these startups that are doing these calculations, it turns out that the dominant part of their cost ends up being that CDN, the place where you're paying Akamai inordinate sums of money to make sure that you have your files on a server in Korea or whatever it is. Turns out that's actually the most expensive piece of this as startups try to scale up. At least that's what I'm seeing when people are talking about it. They're kind of running those businesses. So, and really you could probably do that cheaper yourself at that point. Maybe you won't run data centers, you'll just run your own CDN as like the last mile or something, I don't know. And there's certainly cheaper ones than CloudFront too, depending on what you're willing to do. So here's the plan again. How are we doing? That's why it'll change the world and be like the next big thing, and jump your jobs and go do that. So demo. So wait, again, these are not live demos. I wrote this last night. There was no way that was gonna happen, but I got you to stay here this long. So let's see. I just wanted to show you some examples. So like one simple one, and actually like I know you had worked on a project like this. Now Amazon is shipping automatic Lambda jobs that can post to Slack or HipChat or some of these. So everybody that wrote one of these, basically, you got scooped by Amazon. But let's see. I was just going to bring up some of them and show some of them here. So give me a second. Because I want you to see what they really look like too. Let's see. So here's one. I'm trying to drive while being on another window. And I don't know, is the text going to be too small? Should I zoom in? Zoom in. All right. So pretty simple Python. This one like you pointed out, there's no storage locally, right? So either you upload your configs and your secrets when you upload the function to AWS, and that kind of gives me like, ooh, I don't want to do that because somebody could go that I don't, like if somebody gets into AWS, they can go download it too, so you can pull the secrets back out. And I guess they could do that with an S3 bucket too, but I keep it in S3 so I don't have to update my code every time I update my configs. But this loads a config. It looks for just a JSON file and says, where should I send this? And then this is a function. It grabs the config. It pulls a message out of it and says, oh, if you gave me a channel, I'll use that. Otherwise, I had that default. And it just uses the Python request to do a post. Done. So now anything in AWS that works with Lambda, I can message into my chat channel. So that's actually pretty handy when you want to know that you're running over the your arbitrary billing limit. It can be like spamming you in chat or sending you hip chat or Slack or whatever you use, IRC, SMS, right? Because SMS works with SMS too. So you could do all kinds of things. You don't need a Lambda job for SMS, but yeah, this is just an example. And then like you could do all kinds of fancy stuff with Slack. You could put a meme in there.
On the key thing, one thing I found was that you can use it's lock any, but key storage or key management service,
Right.
where you can provision the function with the rights to get it without actually putting anything in your Lambda, without actually putting anything in the code. You're just provisioning it to the Lambda service to be able to pull a key, and then it does once it's gone.
Right. And so that's something true all over AWS that's nice is that they have these identity and access management features where you can do a lot of delegation. You can never put a key on a server. You can just say it has this rule. So if it ever needs to talk to the Amazon API, it can without ever having to put some long key on it or bake it into your image. I know I do that like with other cloud providers, with like Chef, for instance. That's something I do all the time. It's like you got to have some secret in there somewhere. Even if it's just a root password so you can log in later, like I'd much rather keep as little secret as possible, because then I can put my image or the things I use to build it up on GitHub, and people can collaborate, and I can use tools like Packer, and I don't have to do it on my own in a secret room anymore. So I can use what other people are writing already. To me, that's been the biggest benefit of things like the key management service at Amazon, is I don't have to keep everything a secret. Only the secrets have to be a secret. That, of course, varies by where you work and what they think their product is or should be, but it's nice when you can put it all out there and suddenly collaborate, just as long as it's not your competitors, right? But even that changes all the time in the IT industry. So let's see. So I had another one here. Let me see. Oh, so I was going to show my example of validating that Chef works. This is just a repo with a bunch of Lambda jobs in it and some like test harnesses that say if you get this. Yeah, this is just another example. Also writes to that Slack thing earlier. And it loads the config just like the other one. Let's see, and this actually connects to hosted Chef, and says, was I able to connect to it? Looks for if it can connect with the user that's in the secret in S3, and then sort of chirps in our chat channel and says like, hey, there's a new customer and I can't actually connect, which I care about because we back them up. So if I can't back up your configs, then I don't know, like, and that's a big problem because we do shared management. So if a customer goes and updates something and I don't know about it, like, and I don't have it backed up, it's a problem. So I use Lambda to do that. I have this really helpful message, which I just moved from the channel I idle in to the one that a bunch of support folks idle in. It says, cannot retrieve, probably a permissions error. And they're like, what is this? I had to explain that today, actually, which I wasn't planning on. But I look for some specific users that need to be on all the hosted Chef works with specific permissions as admins. So that's just another example. You're probably starting to look through this and say, wow, how do you test this when it's not, when it runs off in Amazon somewhere? And that's in the next section. Let's see. Are these useful, interesting. They're very like specific, but that's the cool thing is you're not like, I'm not showing you like, this is how I patch the kernel for Heartbleed or whatever, for OpenSSL for Heartbleed or whatever it is. Like, I'm working on the business logic that actually matters to the company instead of like just the Linux stuff, which I think is cool, but like doesn't ultimately pay the bills unless I'm Linux support at Red Hat or something.
Is there a library of the APIs? Like I saw, like it looked like a Slack webhook or something.
Yeah, so this is actually using Amazon's API in Python. It's this library called BOTO3, B-O-T-O-3. And it's actually just something that supports a lot of the Amazon services. And by default, you know that's on all the images Amazon ships. But it's not like a one-off. That's not an API I shipped. I did have to ship some other things. Let's see. Actually, I can show you what those are. So this is like a descriptor file for an uploading tool. Oh, that doesn't have it in there. I think, oh, I know what I did. So this tool, I just have to have a Python virtual env in my directory, and then that will be included in my uploads. I had to go get an Amazon image that had their versions that I know Lambda will run with, and go pip install all the things I cared about that had native components or had to be built. And then just drop it on my workstation, zip it up with this file, and upload it, and I'm done. So it wouldn't be too hard to do native stuff, I don't think. Let's see. And there was one more I was going to show you, which is just, I feel like this is a common pattern in Lambda, which is a job that just takes a giant list of like, this one takes all of the customers and just creates another job for each of them. It's like a common pattern, right? Make it in parallel, like take the one thing off the queue, break it apart, put all the things back on. So kind of not the most exciting, but common one.
Map and reduce.
Yeah, exactly, map and reduce. So, let's see, I forget, is that, sorry the live demos weren't that great. Kind of that's my disappointed memes. No, there's so many of those. Can you imagine being followed around by photographers for 8 years? All right, so limits. Other things about Lambda that I wanted to tell you about. How are we doing on time here? It's been about an hour, so that's perfect. So language choice, that's a big thing. As I mentioned, you can do other languages, you just have to bootstrap them yourself, and you have to make sure they run on that image that Amazon has. It's Amazon Linux. I mean, maybe one day they'll release a feature where you can run it on any image, but I don't know. But that's a painful one, especially if your runtime is large. Like before Java was a supported one, I can't imagine like bootstrapping with JVM. Like 60 seconds is over. Like your function timed out. Sorry, it took too long to install. You know, Java or whatever. Golang, as I said, is great. At first, I tried to write that permissions job and the backup one in Ruby, and I discovered very quickly that Ruby support on some of the Amazon images is not great. There's JRuby. Now the Java supported, it's not like I have to bootstrap a JVM, but it turns out that a bunch of gems don't work in JRuby. They also don't work in this mruby, which is the one that's shipped on the Amazon images, which is like a minimal one. So this is actually like going to be a pain point. You can solve it. So I know you're interested in, you mentioned C and C++, but it's going to be a pain unless everything you're using is like stuff that's just in Linux. If you can build it on their servers though, and it's not huge, then you should be fine. So it will probably affect the time it takes to run a function. You won't be charged for it, but just to time it starts, because they're probably copying that stuff to an image.
I was going to ask about that too, the different languages. I'm assuming they're all like compiled and ready to go.
Right? They're anything on those images, but what's interesting is like Node.js, right, is supported. So there we go, directional mic. Node.js is interesting because all of its libraries are actually plain text already, right? So it's like, that was super easy to upload, really, really easy. As long as you stay in it, it's suddenly very easy. And I think Java, I don't know what people ship. I think they ship a lot of jar files, and those can be pretty big because they generally are not on Linux by default, so probably copying more. And then Python, like I said, the ones I've done is just stuff that's in PyPy, that's in the regular Python ecosystem, and I have to get it and upload it. It can be like 5 megs for the whole thing, but 5 megs isn't that bad, I don't think. Let's see, other things. Right, so identity and access management. That question about like if you can't control who calls it, then you pay for all of those calls. So that is an issue. Like don't put it out on the public internet probably at first. Make sure that it exits if it's not a valid call. Like make sure you're at least paying a minimum for it. The API gateway tool that Amazon has can cover you on some of that because you can have the API gateway deal with requests and then pass them to Lambda. So try to put it behind as many protections as you can because yeah, if the public internet wants your service, something of it has to be on the public internet. So let's see. Performance options. So if you have found there's something in Lambda that doesn't perform the way you want, like that's it. You can add more memory. That's all you get. And you don't have a lot of choices there. EC2 for folks that use AWS, like I don't know how many types of instances there are now. It varies by region. It's like there's database optimized, compute general purpose. There's this, there's that. There's so many EBS optimized. So you have more options. I guess a lot of people say you can mitigate this by at least monitoring for it if you use Lambda, but ultimately if you need to optimize for it, you're going to have to figure out how to use one of those other EC2 instances. Maybe that's something they add to Lambda later. That actually wouldn't surprise me if that gets added. Let's see, some people think that, so Lambda when it fails, you get like CloudWatch log streams, you don't really have like a ton of information why, and it's sometimes difficult to map that back successfully to HTTP calls. So like you have to be really bulletproof about the code you write. So to make sure that if you want to return a 404, like and you don't find something in an S3 bucket, like and it's Python, you need to make sure to have a try, you need to make sure you like raise the right exception, that you catch it the right way. It can be very tricky to get exactly the semantic meanings back from HTTP responses when you're running them all through Lambda. So as a subtle Lambda, I think like it's easy to mess up probably, unless you just want your API to return 500 for everything, which people do sometimes.
Well, why not? I mean, what are you? What's
500 makes people call you, like you're broken. Whereas like if it's 404, it's like no, that's not there. So just return 404 the whole time.
Yeah.
Any error, 404. That you get much fewer calls about that. Like I said, the dependency packaging stuff, C library is probably not a big deal. I was talking to a guy I work with loosely that's in another part of Rackspace the other day, and he was building SSL for himself. I was like, ooh, anytime you compile crypto libraries yourself, like I get that thing about like don't write your own crypto. I mean, it's not writing it, but it's that whole don't be responsible for this. Like let Amazon patch OpenSSL on their images, and the next time my function runs, it just works, and it's not vulnerable. So that's one. Testing. So this one's weird. A, because if you're using other AWS services, you can't really test those either. But B, also because even if you're not using other AWS services, it's very difficult to like replicate exactly that environment unless you run your tests in Lambda, which you could do. But you know, you're basically reinventing orchestration around Lambda to run your tests to simulate Lambda, right? So you're like, oh, spin up a VM with the right flavor of Linux and all this stuff, and it's like you just written Lambda to test your functions. So maybe test them in Lambda in a non-production environment. That's probably better. Does anyone have any other experiences with that? I feel like anytime I give AWS testing advice, it's like you just have to go test it in AWS. No?
I mean, that's pretty much it. Like
That's it.
you can write discrete functions and make sure they call back.
Like
So,
unit testing, but that's it.
yeah, I mean, like you can get around the key management and the role stuff by having it done locally and like using a library that can access it.
And at some point, you're like stubbing so many things too. Even if you try to not access AWS and pay for it to run your tests, you're like basically simulated that all of your stubs work, and you're not even testing Lambda anymore. So that's another interesting one. If you want to travel and work or be somewhere else and work, connectivity is a big deal and stuff like that. If you're not connected, like you can't really test everything. So there are some cool ways of doing it. There's a Python project for testing it. There's a library for Node that has some testing features in it. But my sense is the ones that are the most robust have basically written some sort of framework around Lambda, where you write a function or a method with their method signature and their runtime calls it. And you upload their runtime to Lambda. And so it ends up being like this complete wrapper, and they're basically testing that your internal, the function that they're wrapping with their framework works. So again, it's sticky. Also, there's no real structure to it, so it's like you can upload anything and everything to Lambda, and it's one giant list, and lists are best data structure for lots of things. No, I'm sarcasm. I got some lists.
No.
What do they do? No, lists are terrible when you have like 500, 1,000 functions. Like if you really implement your whole site in this, like you might have a lot. Especially if you try to parallelize it, figure out what's slow and make it its own function.
I think I've tagged.
You can tag things, but it's still like, it's still basically a list. Like there's no nested structure. So you can't be like, these are all the read functions, and these are all the ones that write, and these are all the ones that I want to make sure don't have permissions to talk to this database. Like that gets sticky. Also, it's not supported in all the places that AWS is supported. So like if I saw one guy who was in Asia, and he's like, man, I would love to use Sydney in the AWS region in Sydney, but doesn't support Lambda. And Oregon is like really far away from Asia, you know. So there's that issue, which is weird because most of the AWS services are spread really, like they just have presence everywhere. I think they just announced Korea, was it? Yeah, like they're everywhere. They're like in all these places like Brazil and places in South America where there's no other data center or cloud provider. So
there's some evidence that routing through CloudFront, like using zero actual forwarding, can sometimes be the fastest route.
Right. So Derek's comment is it still might be faster to send things through CloudFront. I've seen that too, where people have said like, oh, well, it was actually faster for me to just use the CDN and put it in Oregon, but I don't know. I guess it depends what you're doing with Lambda. It probably doesn't work overall. So also latency. 1 second for an initial call. So like if you have an application that needs to respond in less than a second to a really big burst of traffic, probably not going to want to wait for some file to be copied to an instance and unzipped. So that could be a thing for you, or you might need to start warming it by making the calls yourself. But even then, you'll only be able to ramp up so quickly with something like Lambda. You know, they're probably tuning it for specific scenarios, and if your ramp up scenario is not one of those, you might be in trouble you might have to move over to AC2 to get that kind of ramp up.
If you make a call regularly though, and even if the function quits, it will resume. Like there's always
right. So you can keep it warm that way. You can just make calls regularly, but it still doesn't guarantee that there's still like going to be some point at which it is not going to ramp up as fast as you want, even if it has. I mean, if you want it to be faster, you have to make more calls regularly. And then if you want it to be faster for a larger data set, then you need to make more calls regularly. You start like basically, I have to have this load all the time if I want it to be ready for this load. So like eventually you're fighting yourself. So that might be a thing. I don't know. That seems like a corner case though for people with very specific needs. Also the never catch up problem. So like, if your Lambda job calls other Lambda jobs and it takes a long time and they call Lambda jobs, they call two friends and they get, you know, like you start to fan out thousands of Lambda jobs, and if none of them ever finish, they can be bogged down. So like you have to be careful if you do a lot of nesting that you don't have a runaway situation. So, I mean, same is true in your own hardware, and then it just falls over, right? But if you're paying for it, you need to watch for that. Vendor lock-in, like I said, maybe, maybe not. Maybe not for Lambda, but maybe for other things. You really, unless you want to run the entire like AWS suite of products and make your own cloud provider, in which case, like, good, that would be awesome, but it's a lot of work. I think it'd be hard to catch up at this point. So like, you're probably not gonna do that. But if you can compete against Amazon, compete against Amazon. I mean, it'd just be a lot of work. Competitors also, I didn't know this before before writing this talk. It's actually like there's other services like this out there. Facebook has one, which they have not. I guess I wish Ben was here, who's given a few presentations here before on things like JavaScript. He's going to work at Facebook, and I wish I was here because maybe he's on the stream. But I would want to know what he thought about some of these other options. But like the Facebook one is called Parse, and it's really interesting because their whole model is like, yeah, general purpose compute is like interesting, but all the money is in apps. And so like their platform is just designed to be a backend and do all this stuff I already talked about, but just for mobile apps. So it's kind of interesting. Like they've said, all right, here's where the money is. So I don't know, but there's other ones out there. I still use a computer, so like I'm still, maybe I'm not the right, maybe people using Facebook that are younger than me don't use other apps, but like I'm not just a mobile app person, so.
You're beginning to look old.
Yeah, well, takes one to know one.
Oh, shots fired.
But yeah, that's it. I just kind of wanted to give you like this, here's the futurist perspective, and then like here's all the details, and here's some stuff you can do with it. Go try it. And that's it.